we're going to work on a project, and we're actually going to be doing this for the next week and a little bit. It looks like we have until next Monday to complete this particular project. We might get done, excuse me, we might get done by Friday. We're going to shoot to get done by Friday, and if we need to take an extra day next Monday, then we'll do that too. We'll do that to finish up. But anyway, what we're looking at here, let's see, that's not it. That's not right either. Let's get the right thing opened here. Okay. So a few years ago, when we started this course, I was looking for projects that I thought would be good enough to show us how to do engineering, to give us some engineering experience and skill, but also would be easy enough to send home, and we could send parts and tools and everything else out to the schools that we were teaching this class to. And I found this website called Teacher Geek, which is actually run by some educational company, some other educational company, I can't remember which. But essentially what this company is they make all these little parts, and they sell all these little parts that are going to give students an opportunity to learn some of the engineering basics without having to have a $10,000 lab and thousands of dollars worth of equipment every year. And so if we look at some of the things that they've got here, let me see if I can. Let's go look at here. So, for example, this is one of the things that I've sent you is a few of these connector strips. They're essentially like a little beam of plastic with these holes already pre-drilled through it. And they're designed so that you can build things that have dowels pushed through those holes. And you can ream out the holes so that the dowels will spin, or you can leave the holes as they are so that the dowels will be stuck in there. And so this is just one of the many things that I have purchased. I think I purchased like a bunch of 50 packs of these things. I sent you 5 or 10 of them. I've also sent out dowels. These dowels, I've sent out several of them. These ones here these are yellow tubes that they call slide stop material. So these tubes can be cut, and I think I've even sent you a pair of these cutters. If I didn't send you a pair of these cutters and you want a pair, I can send one out to you. Or you can just use any kind of pliers / shears or whatever else. But once you put these on to one of the dowels, it will essentially prevent the dowel from sliding around, because it will stick. It's just barely big enough to fit around the dowels that I've sent you. So it prevents a little stopper. And you can see kind of how they've used these, and you'll see other examples of all of these things. Other things that I included are mixed gears. So you have all these different size gears with different radiuses and different numbers of teeth on them. And of course you can use gears to do all kinds of things. You can make reduction gears, and you can make all kinds of other things. You can combine these gears also with pulleys, which I also have included, pulleys with rubber bands. And then you see this platform underneath it. I don't remember what they call this, but I've included a couple of those in each one of these kits. It's a platform with holes in it so that you can make a little base or something with. And those are useful. What I have included the most of by far are actually see if I can find them. Because as engineers, we want to try and design as much as possible and not just build things. With these plastic things, you can do a lot of building, but you're not necessarily doing a whole lot of designing. Is there a search bar on this thing somewhere? Here's a search bar. So, so one of the things, I don't know what they call them, I'm trying to remember what they call them, are just these wooden sticks. And let's find them really quick. Here they are. They call them basswood strips of wood. And they're essentially like a little 2x4, but instead of being 2 by 4 inches in dimensions, they're like 2 by 4 millimeters. They're not very big at all. They're about 12 inches long, and they're essentially just little strips of wood. And I've given you, I think, maybe 100 or more of these things. And these are extremely useful. Yeah, for an engineer to design with. You can drill holes through them, and I think I've even included a drill bit. If I didn't include a drill bit, you can use whatever drill bit will work to drill through them so that you can connect them using different things. You could also glue them together, you could nail them together, you could wire them together, whatever you want to do in your particular design that you're making. This is the biggest group of tools I've given you. I've also given you a bag of hardware, a bunch of screws and bolts and nuts and washers and other things. But for engineering, it's really a good idea to give the basics so that we can work with those to build a design or to create a design, and then to build whatever it is that we're building. So this is most of the projects we're going to do are going to involve things from this website. And that even includes the labs. They actually have a fair amount of good labs already built. So I go ahead and I take some ideas from them, quite a few ideas from them, and we're going to use those in our courses here, in our course, as our actual experiments or our projects. Let's see what I got here. I can't talk and think at the same time, apparently. There we go. So, anyway, that's where we're at. So let's need to move some of my stuff here. Okay. The first one is the bridge. And this is the guide that we're going to use to do this project. And I will email this to you at the end of our class today. And for the first day or two in this project, your job will be to complete about the first 9 pages of this activity guide. So what this activity guide is going to do for us is it's going to give us a fairly good representation and outline on how the engineering process works. You'll notice that we have some pictures of bridges on the front page here, and you could use a design similar to one of these, but I really don't want you to use just a copy of one of these designs. I want you to create a design that is much more your own. But these do give you some ideas of what you can use. I have included many things in this kit, but I have not included enough plastic strips for you to do what they've done, which is make a bridge almost completely out of plastic. I've certainly given you enough wood to make a bridge completely out of wood, but I've also given you things like wire and string and other things that you could use if you wanted to. Now, here is a list of supplies that they say that we've given you. And essentially what I've given you is I've given you everything that you have in the kit that comes. And you don't want to use it all because you have many projects down the road. In fact, what you want to do is you want to use as little material as possible and still build a bridge that meets the requirements that I'm going to give you. Because the idea as an engineer is to be kind of a minimalist. You want to meet the requirements and maybe even exceed the requirements a bit, but you don't want to over-engineer and you don't want to over-purchase on a project. Materials cost money. If you're building a bridge in the real world that's going to carry cars across it, I guarantee you it's going to cost in the millions of dollars. Maybe in the hundreds of millions and maybe in the billions of dollars, depending on the size of the bridge. One of the more famous bridges built recently is probably the new San Francisco Bay Bridge, and I think that one came in at $1 billion or more. And so bridges can cost a lot of money, and if you put just 10% too much material into $1 billion bridge, you're talking $50 million, $100 million of wasted money on material that just didn't need to be there. Not to mention all the labor and design cost of actually using that material. So what the ideal thing to do in any design in this class is to meet the criteria with the least amount of material possible. So I'm not going to give you some numbers in here. They say 10 standard basswood strips, 10 standard basswood dowels, 10 standard plastic canisters. I'm not going to tell you how many that you can use or give you a maximum you can use or anything else. I'm going to tell you to use the least amount possible. If you want to use anything else in the construction of your bridge that is not included in your kit, not including tools, you can use whatever tools you need. But if you're going to use any materials besides what's in your kit, please ask me first. Right here they wrote glue, and I did not include glue in the kit. I'm always afraid it's going to break open in the mail and make a big mess in the box or whatever. I did not include glue in the kit, so if you want to use glue, go ahead. I recommend wood glue. Wood glue, a lot of people get frustrated with it because it takes time to dry, but for gluing wood together, there is no better thing. Just the regular old yellowish Elmer's or Type Bond wood glue. It's the best stuff for gluing wood together by far. Now it does take time, so you got to be a little patient, but I would recommend it. On this next page, they actually talk about the engineering design process, a little bit different than we've seen it, but I really like this particular engineering design process. It is a cycle. Now, I think it would be better if this cycle had arrows that went across the middle of the circle so that you could show that you can skip steps or you can go back to previous steps very easily. But you still get the idea here, and the idea is that you start off with a problem statement and a design brief. In other words, what am I trying to do, and kind of what's the basics of how I'm going to try to do it. Right? I'm trying to mow the lawn, but I don't want to do it myself, so I'm going to try to design some kind of automated lawn mowing machine. And that would be a problem statement and design brief. Okay? Investigation and research. Right here you're going to see what other people have done, what's already been done. Maybe learn about lawnmowers in general if you've never built one or never designed one or never used one. So it might be a good idea to understand a little bit about lawnmowers. It may be really important to understand about lawn mowing. You may want to go out and interview some professional lawnmowers, right? Generating alternative solutions. That's where we're going to actually start thinking of ideas, getting them on paper, and figuring out what we might do to solve this problem. And then we're going to choose the best solution out of all the ideas that we generate. Once we've chosen that solution, we'll model and prototype. Notice that we've gone through 4 steps of the process, and we haven't done anything until step 5, involving actually any kind of building. Modeling and prototyping is the actual physical building part of the design process. And then we test and evaluate to see if our design has worked out. If it hasn't, we start over. But we don't necessarily have to go around the whole circle again. Maybe we start over at choosing the best solution. Maybe we discover when we test it that one of our other solutions probably would be better, and we'll try that one out instead. Or maybe we discover that one of our solutions that we tried was terrible, or whatever. But or just failed altogether. But anyway, this cycle, I kind of like the way they've represented it, except that I might include some arrows going across the middle of the circle. Here's another tool that you may use during the design process. Particularly this tool, the West Point Bridge Designer tool, you might use in the investigation and research, or even the problem statement and design brief, but certainly you would use it in step 3 in generating alternative solutions and choosing the best solution. So the West Point Bridge Designer is actually a program you can download. Let's go ahead and take a look at this website really quick. Hopefully it's still there. Every year at several colleges around the world, they have a bridge building and bridge designing contest. And this is was the website they use. Let's try to do a search for it. Here it is. Looks like it's got to do a new home here. So it's called Engineering Encounters now, the Bridge Design Contest. And the software you can download for free, and you can run on Windows or Macintosh computers. It turns out they're not doing the design contest anymore. They decided this year to end it, but that's okay. We weren't participating in it anyway. We were just using this software to design. And it's actually, I think that you can actually use it online. We used to be able to. Let's see if we can. Let's see if we can run it online. Yeah, West Coast. Let's see, West Coast Bridge Platform. I don't think that's right. That's an actual bridge company. This is it right here. So this is a similar one. This is from Johns Hopkins University, I believe, where you can build some trusses. You can build a bridge truss. Trusses are essentially these members, these solid members in a bridge that form those networks of triangles, right? And that is one of the simplest ways to one of the simplest ways to design a very strong bridge is to design a truss bridge. And so here's what the program looks like. You can add members, which are essentially which are the actual trusses themselves, which are the beams themselves. You can add nodes. You have to add nodes first, it turns out. So nodes are where the trusses connect. So I'm going to add in a bunch of nodes, and I'm going to just add them at random here. You probably want to design and then add them some kind of proper way. And then I add members by dragging members in between each of these things. And then you can actually add a load in. So if I add a load, I click on one of these nodes and I drag down to add some load. Maybe I want to drag sideways to add some load. So I add some load there, I add some load here, whatever else. So I'm adding essentially some forces on here to see how it's going to go. And then they're going to have you calculate. So right here it says members plus 3 must equal twice the nodes, and so I don't have enough members in here. You can see I didn't finish off this triangle, I didn't finish off this triangle. I did that on purpose to show you this little design feature, so let's add some more members. It'll tell you that it's just not a proper truss design without adding these 2 extras. Then I'm going to go ahead and calculate. And then it says there must be 1 fixed node and 1 roller node. Well, on a bridge, that is true. And usually those 2 nodes are at the ends of the bridge. They don't necessarily have to be. But what they mean is that one of these nodes needs to be connected to the ground somewhere, or to a tower, or to something. And it needs to be fixed. In other words, it does not move. So I'm going to click on Fixed Node, and I click this node to call it my fixed node, and it puts a little thing under it that makes it call it, that's a symbol for a fixed node in engineering. And then I'm going to establish a vertical rolling node, or sorry, a horizontal rolling node. You can do a vertical or a horizontal. I'm going to do a horizontal on this one right here, and that is the little wheels under there is the. I think I can zoom in on this really quick for you. Maybe I'm not. Maybe not. But anyway, I can't zoom in on the picture apparently. But they give you the symbol for a rolling node. It's like 3 little wheels on a surface down here. So that means that this end is locked down and this end is allowed to roll a little bit. Now the reason that they want one end to be able to roll is because the bridge will expand and contract in the weather and temperatures and everything else. But also the ground will move. And if you don't allow the bridge to change or to move or to adjust under those conditions, it will break the bridge. There's no doubt about it. But not only that, as you load it, it will stretch and twist and torque and everything else. So you have to allow one end to move so that it doesn't break the bridge. So now that I've got all these things put on here, I'm going to go ahead and calculate now and see what happens. I'm going to click anywhere on the grid to calculate forces on the grid. So I'm going to click on this member right here, and it's going to show me all the forces involved. Now how is that going to help me? Well, the blue areas show you which parts of the bridge are going to be compressed under these loads right here. When you add in these loads, these are where you're going to get compression. The metal is going to be squished. And then these red areas are where you're going to get expansion, or what is called tension in engineering. So compression and tension, or squishing and stretching. But they also tell you how much. For example, you can see right here, you've got 135 right here in the middle of tension, right? And you've got 114 up here of compression. You may want to design this a little bit better so that evens out a little bit. Because right here in these two members right here, it's 6 and 5. You don't hardly have anything going on here. And maybe we can adjust things, adjust the angles, adjust the number of nodes, maybe adjust where the nodes are, adjust the number of members, whatever, to account for or to even out some of these loads, so that we don't have some things that have to be super strong and other things that are going to be fairly weak. That may not be the best idea. However, you also have to consider the weight of these things, because each of these members has weight. So the heavier stuff, if you have a lot of heavy stuff in the middle, it's going to create a load in the middle. So maybe having low tensions and low compressions in the middle is a good idea, so that you can have a fairly small, you can have lighter weight materials in the middle. So there's a lot of things to consider, and those are some of them. And this program can help you to do that. So Bridge Designer, which is at pages.jh.edu/, and then it's got the Segelia virtual lab /bridge/bridge.htm. And I will send you that link along with the link to, or along with the document that we're using today. In fact, I think I may have included in there. If I haven't, I will right now. So let's add in right here, let's add in a link for our own Bridge Designer software. You can still use the one that's included here, but this one right here, http pages.jh.edu/virtual lab bridge HTML thing. That is the one that's online, so you don't have to download anything if you don't want to. Okay, so now moving on. The thing that this other Bridge Designer will give you, the one that's the West Point Bridge Designer, is that it will also draw your engineering drawings for you, which you will have to do in this class. It gives you a drawing with a scale and very nice features, things that are labeled, and also put your name and everything in the corner, which is what you want. You're doing an engineering drawing, so that's kind of nice, but it's not absolutely necessary for this project. So, the problem statement. What is my problem? And then, what are the design constraints, right? So the problem is obviously you need to build a bridge, right? We need to build a bridge, but there's a little more detail, and that's where we get into this design brief. So in the design brief, it says that we have to span an 18-inch gap between two tables, and it must support a 2-pound load at its center. Okay? So down here, I'm giving you a little bit of a hint. Our building kits are not the standard kits for this project, so you should not try to make the bridge that is in the pictures. I would recommend a truss bridge of some kind. Also be aware of the activities/questions that you are to complete throughout this worksheet. So there's not just designing to do, but there are some activities and questions related to this. And then down at the bottom here it says, your final bridge will be tested until it fails under load. That's not necessarily true. If you don't want to destroy your bridge, you don't have to, because you will be doing the testing, and you will be taking a video of your test and sending me that video. But what you will be doing is you will be testing your bridge up to 2 pounds, but since we're engineers, you might go up to 5 pounds, or 3 or 4 pounds, or something like that. Because you don't want, as an engineer, you don't want to just test to see if it does exactly what it needs to do. You want it to maybe do a little bit better, so that there's a little bit of safety, a little bit of fail-safe. So the maximum deflection is reached if a bridge deck bends over 13 millimeters, which is a ½ inch. So you don't want the bridge to bend more than a ½ inch over an 18-inch span. Okay? And then if one or more of the bridge members breaks or cracks all the way through, in other words, it completely breaks, then we're going to consider that a fail also. So these are the two things that we're going to test for, and part of your grade will be dependent on that. Not all of it, but part. We've already talked about the materials to be used. And now we need to talk about coming up with ideas, the design process. So this is page 6, and this is kind of where you're going to start with your project. There is one other thing that you should do at the very beginning. I didn't mention that you should do this, but if you go to the very beginning, the problem statement and the design brief, from the design brief, you should create a 1 or 2 sentence problem statement. So this part right here where it says, what is your problem? They're not asking you for any personal problems. They just want to know what is the problem that we're trying to address with this project. So you're going to answer that question with a 1 or 2 sentence statement. Make it very general and very, but give enough information that we know what we're doing. We know what this project is about. And then you're going to skip down here to generating alternative solutions. At this point, you need to go out and do some research. You need to use the bridge design tool. You need to look on the internet, look on Google for different types of bridges. Maybe you're interested in doing a truss bridge, so you look at truss bridges, but maybe you might want to consider several different types of bridges. Some people will do 3 different types of truss bridges, but I find it more interesting when an engineer does maybe a couple of truss bridges, maybe a suspension bridge, or maybe a couple of truss bridges and maybe some other kind of bridge, whatever. But get a little bit creative with the ideas that might solve this problem and meet the requirements of the design. For each one of the designs that you choose, which you should have 3, you should have 3 designs in the end that you think are good designs of all the things that you research. For each one of those, you want to just put them on what we call alternative design sheets, which are included in this packet at the end of the packet. Now, if you want to just put them on some graph paper of your own choosing, that's fine too. But it is included in this packet. So start off by drawing what they call the abutments, which are essentially the pillars on each side of the bridge that you're going to connect the ends of the bridge to, those are essentially your tables. And you should have 18 inches from the inside of each abutment to the other inside of each abutment. So it should be 18 inches from this point to this point. Now, the graph paper included here does not necessarily have everything set up just right for you. Let's take a look at that. Here is a let's see if I can find one of these. Here is an alternative bridge design sheet. They give you 3 of these. And they have a little section up here for the top view of the bridge, and a section down here for the front view of the bridge. And notice that along the bottom here they have things in centimeters. I didn't ask for it in centimeters. They just gave it to me in centimeters. And so you may want to change the scale at the bottom of the sheet. Maybe change it to inches or whatever. But essentially you want to have 18 inches across this thing. So you can split it up however you want. If you split it up so that every 2 is 1 inch, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches on each side. So you'll have 12 inches on each side of the 0, 12 inches to the right, 12 inches to the left, and that should be good enough. And just scratch it out here on the bottom and make or widen it out or whatever you want to do. Or you can use your own graph paper, either way. But each one of these sheets should have a design on it. And this design should not just be chicken scratch. It should be well drawn. You should use rulers to draw straight lines. And if you need to draw some kind of a curved line, you should use some kind of a curved tool to draw a curved line. It shouldn't just be sketched out. These should be drawings that are to scale. They should include everything that you might put in the design. They should include wires and strings. If you're going to drill holes, those should be drawn in there. If you're going to use things that are round, they should be round. It shouldn't just be a stick drawing or something like that. So these should be drawings that are actually representations of what you would like to design, what you would like to maybe build in the end. Oh, actually, I'm wrong about that. I forgot. The real drawing comes at the end. These ones are actually kind of like stick drawings. I forgot about that. Because they don't give you enough space to draw them out for real. They kind of do, but only if you draw really small. So, I apologize for that. I should have turned to the next page. But here they show you a way to show what you're using without actually drawing like the little 2x4 strips. And the way that they show you to do that is to use either different colors or to label them with letters. So you can do it that way. So right here they have C is for wire cable, P is for plastic strips, and then if it's not labeled, then it's all considered to be wood. So you can do it that way and have a little key showing what is what on your design. That works fairly well, especially if you use colors, like if wood is all red and plastic is all blue or something else like that. When you do your final drawing, you want everything to look just like it would. So that one will be different. Final drawing. The top view, of course, is going to be quite a bit different than the side view. It's usually going to just look like this, showing things that are connecting 2 different sides of your bridge. And you certainly want 2 sides to your bridge. If you don't have 2 sides to your bridge, then you will not have a very stable bridge. So you'll have 2 sides that look essentially the same, connected in between with some kind of connectors. And they give you some fairly good like tips and tricks to do how to do this well through here. Once you have all 3 of those drawn, then what you're going to do is you're going to turn them into me. So up to this point, what you've done is you've stated the problem, you've researched different kinds of bridges that you might design, you've chosen 3 designs that you really like, that you think are the best 3, and then you've drawn them out with the types of materials that you would use in which places and how long each of these members would be, and so on and so forth. So you're giving a fair amount of detail in these alternative designs, even though they're not as detailed as the final drawing. And then you will turn them in. Okay, so 3 alternative designs turned into. Today is Monday, and I would expect all those 3 of those designs to be turned in on Wednesday. And then on Wednesday, we will talk about how to choose a final design. We will do what we call an alternative design evaluation, which is actually something we'll talk about right now. And then you will choose your final design from that. Do you have any questions so far about what you need to do for this project the first day? Is it making it pretty clear? Okay. So this is the last thing for today. I'm going to zoom in on this a little bit here. Let's see if I can. There we go. At the bottom of each of your alternative design sheets, there is this thing called the design evaluation. And you're going to give your design a score out of a total of 60, it looks like. And the 4 things that you're going to give it a score on are meeting the design constraints. In other words, the requirements that I gave you at the very beginning. Does it span 18 inches and so on and so forth. As far as you can tell from the drawing, does it meet the design constraints? And be honest, you know, if it meets them mostly, but maybe you can see a flaw, maybe give yourself a 25. None of these should be really a perfect score. There's no such thing as a perfect score in engineering. None of them are going to be perfectly meeting design constraints or perfectly functional or perfectly aesthetic. But you should give it a very honest score. So meeting design constraints is a big deal. Some number out of 30. Function. So is this a bridge that would function well in the real world if it needed to be a bridge for a train or a car or something? For example, if your bridge has a huge amount of material on the ends of the bridge that gets in the way of people crossing the bridge in some way, that might not be such a great idea for a bridge, right? Aesthetics. Does the bridge look nice? Important? Absolutely. Human beings want their world to be aesthetic, aesthetically pleasing. And then economy. How many pieces of material are you using to build this bridge? How much time would it take to build this particular bridge? And give yourself a score out of 10 for being as low as possible in those 2 regards. You want to be low on time to build it and low on materials to build it. Okay? So more complicated bridges are not very great economic bridges, and bridges that have more materials are just not as economic. And then you're going to do that for each one of the 3 designs that you turn into me. Okay? And that is the second part of what we're doing for Wednesday. So, to answer the question at the beginning, you're going to research bridges. You're going to find 3 designs that you think are the best ones you saw for this project. And you're going to draw them and evaluate them. Draw them, label them, evaluate them. Okay? And that takes us through a huge part of the design process. Okay? Probably about 2/3 of the design process, well, maybe about half of the design process is represented by these first 8 or 9 pages of the text. The next thing we'll do, and we'll talk about this on Wednesday, is to pick one of those designs and create a final design. And if we have no more questions, that is all we have for you today. Are we good to go? Okay, I will send that email here in the next few minutes that will include some links to bridge materials and this bridge guide here. I'll attach this, and we will see you later.